All right, so 3B.3 note special case factoring, okay? So special case factoring is just basically someone sat around and realized, oh my gosh, there's patterns to this, right? When certain things happen over and over, that's a pattern. Now we make it a rule. Now we make it something that we can always do once it's recognized. The thing is, when you do these patterns, if it doesn't feel comfortable to you, you can always fall back on what we've already learned. Does that make sense? Patterns are just meant to be, these are just meant to be shortcuts, but do you have to use them in a shortcut? No. It is, and I don't know why. I haven't touched anything. All right, so example. We have example number 1. It says a squared minus 1. A squared minus 1 means that you have a middle term. Your B term is 0. Does that make sense? Because anything times 0 is going to disappear. It's going to go, right? So in the middle, you have 0x, right? So back on what we've learned how to do with this, we talked about when this happens, it lets me write. Let's try again. I just want to write. Okay. We talked about that when it's simply a trinomial where your leading coefficient is a 1, all you're asking yourself is what multiplies to give you -1, but adds to give you 0, correct? The branches, do you all remember doing that? So when we talk about that, what would be my numbers that would work? It would be a -1 and a +1. That's because -1 times 1 equals -1, and -1 plus 1 equals 0, right? That's what that mental math process comes in. Okay, so therefore your factors would be x minus 1 and x plus 1. That's the only way that the middle term is going to cancel out. So to show that it's going to cancel out, we're going to use FOIL. So FOIL, aka just multiple distribution. We have x times x, which gives us squared. We have x times 1, which gives us 1x. Our inside, -1 times x gives us -1x. And -1 times 1 gives us -1 squared. We simplify and we get x squared. What happens to a positive and a negative of the same value? They cancel out, right? And all I'm left with is x squared minus 1. I don't know why I used x instead of a. It was very confusing, but please turn all your a's into x's. Where you have an a, make it an x. Okay, so that's why that works, is that I'm going to have opposite. So when that comes into play, the same thing here. So for example, we have 9b squared minus 4. 9b squared minus 4 means that we're missing that middle term, right? We're missing our middle term. So then this would actually is saying 9b squared plus 0b minus 4. The difference here is that our leading coefficient is 9, not 1. So it doesn't make it an easy problem, right? I can't just simply say what multiplies to give me -4, but adds to give me 0. I'm asking what multiplies to give me my C times my A, right? My C times my A is -36. And I'm asking what adds to give me my B, my middle term. So what adds to give me 0? What numbers would multiply to give me -36, but add to give me 0? What two numbers multiply to give me -36, but add to give me 0? A -6 and a +6. Oh my God. A negative has a positive is a negative, but a negative plus its opposite is going to be 0. So that's why this ends up how that ends up working. So we would do the X and we would go into the box and do all of that. However, someone's like, this is a lot of work to just factor, or the grouping method, or however. So we have -6b, -6b, and we plug them in. Okay. Well, the viewer can just look at the board. So remember, inside this box, this is our GCF box. So around this box, you're finding the greatest common factor. The greatest common factor in my first row is 3b. The greatest common factor in my second row is -2. The greatest common factor in my first column is 3b. The greatest common factor in my second column is positive 2. So notice that it ends up being 3b plus 2 and 3b minus 2. Looking at this answer and looking at what we got here, what do you notice? What is something they have in common? They're opposites. One is positive and one is negative. We're adding and subtracting. What else? They're what? They're recurring. Okay, in what sense? The terms are the same, right? So the terms are the same, except one is a positive plus term. One you're adding, one you're subtracting. Do y'all notice anything about the original numbers? Do you notice anything special about x squared and 1 and 9b squared and 4? Yeah. What are they? They're perfect squares. They're perfect squares. And what operation are you doing with these two perfect squares? You're subtracting, right? So you have perfect squares and the operation is subtraction. So what someone realizes that every single time I am subtracting two perfect squares, instead of having to put in a 0, I can just, what's the relationship between 9b squared and 3b? It's the what? What's the relationship? How can 9b squared become 3b? The square root. 3b is the square root of 9b squared. What's the relationship between 4 and 2? It's the square root. So someone realized if I take the square root of these two, I can easily factor without having to do all of this extra work. Does that make sense? So they came up with what's called the difference of two squares. So we're going to try their rule out loud. Okay, you're not writing this down. We're doing it. What does it say? Out loud. All right. So for example, are these both perfect squares? Yes. X squared and 9 are perfect squares. Am I subtracting the two perfect squares? Yes. So because they're perfect squares and I'm subtracting them, to find their factors, all I have to do is take the square root of the first one, the square root of the second one. X times X. It literally has a square on it. Like it's X squared. Like it tells you I'm a square. It could be the sides, like unknown sides of a square. X by X. Unknown by unknown. If it has a square, a 2 on it, it's automatically a perfect square. That means that a variable times itself produced that. Okay? So the square root of X squared is what? Square root of X squared? Hey guys, a lot of y'all who are talking are going to be one say, I can't do this and ask me questions. What I'm going to say right now is we're doing this together right now. I'm asking you, what is the square root of X squared? If we cannot as a whole class say the square root of X squared is X, then we are epically failing you in math. What is the square root of X squared? X. Why is that the square root? Because X times X makes X squared. That is all I'm asking you. That's it. This is the base level. If we can't do this, you can't do any other problem. So if you're not answering me because you don't know the answer, then you need to say something. If you're not answering me because you find this unimportant, then that's a different situation. Then you tried, and I respect that. So the square root of X squared is X. The square root of 9 is 3. So your factors are X minus 3 and X plus 3. That's what the pattern they realized is that every single time you are taking the difference of two perfect squares, there's a rule to follow. And that rule is simple. Instead of having to do this every single time, putting a 0 back in its place, doing the X or doing grouping, guess what? Someone recognized the pattern and said, oh, we can make this way easier. And because they recognize that pattern, you now only have to follow that pattern. So when I ask you, let's try to do this out loud, It's me trying to make sure we understand what we're doing, especially when it's something that's meant to be simple and helpful. So, B, what is the square root of x squared? What is the square root of 25? And you're going to have a minus and a plus of it. What is the square root of y squared? What is the square root of 64? 8. And you're going to have a minus and a plus of it. By the way, it does not matter which one you write first, whether it's minus or plus, you just write them. Okay, next, 4a squared. What is the square root of 4a squared? 2a. What is the square root of 9? 3. So we have a minus 3 and a plus 3. What is the square root of 49x squared? 7x. What's the square root of 1? 1. You're going to have a minus and a plus. What is the square root of 9a squared? What is the square root of 16b squared? Or what? Or b. What is the square root of 36m squared? I'm going to go back in a second and ask you, what did I do wrong here? 100 and 100 n squared. So I have 6m, and then I'm going to also have to have, what about a fraction? What is the square root of 1/4? No, when you have a fraction, you're taking the square root of the numerator and you're taking the square root of the denominator. What's the square root of 1? 1. What's the square root of 4? 2. So the square root of 1/4 is 1/2. So we have 1/2 x minus 1, and we're going to have 1/2 x plus 1. Okay, 64. Square root of 64. 8. What happens again with the fraction? 3/5. Okay, now let me highlight which one we got wrong. We got F wrong. Oh. F is wrong because F is a positive. There's a plus in the middle. Therefore, I did it on purpose. I did it on purpose so that we can come back. Yeah, April Fools, gotcha. No, this is to show you that this rule only works when you are subtracting. Okay? It only works when you're subtracting, because if I was to FOIL this, it would not give me a positive 16b. It would give me a negative. A negative 4 times a positive 4 is going to be a negative. So this would not work. So what we call this here is a prime, because I can't factor it. What it produces is imaginaries, which is later on in our lives to worry about. So right now, it's just a prime. So if it's the sum of two squares, can we do anything with them? No, we only can do anything if it's the difference of two squares. Does that make sense? All right, so whose turn is it?
Your turn.
Your turn.
April.
Okay? Because in the end, if the A term and your C term, so your beginning and your end, are perfect squares, then you factor them, and you're going to add or subtract the roots. So here you go. Do it. I'll give you 2 minutes. Check with your neighbor. All right, so really check on the first one. What should we have? We should have x minus 3 and on the next one, 4. And perfect on 5. Perfect. And then 6.
5k minus 8.
There we go.
Then a plus 8.
Do we understand the rule now? Easy peasy rule?
Oh.
Okay. So aren't you appreciative of someone recognizing the pattern for you? Yes. All right, on to the next part. If it's what?